Hello grade 12s, welcome back to our video lessons. So we are going to start off with going over the corrections from the exam questions that I gave you. So we'll start with question 2. So you're given the following table, okay, and we start with 2.1. So 2.1 is a part of this portion of the table. It tells you there's an alkane, it gives you the general formula, and it gives you the IUPAC name. It wants to know the structural formula. So basically we are drawing 2,3 dimethyl butane. Okay, so as always, the best place to start is to figure out the functional group, and they've already given us the homologous series. They've already given it as alkane, so we know that there's just single bond hydrocarbon. Okay, so let's have a look. We first start with our carbon chain as usual. So it's butane. Butane is 4 carbons. So we'll do 1, 2, 3, 4. Then it says 2,3 dimethyl. Okay, so let's number it ourselves. 1, 2, 3, 4. So it's 2,3 dimethyl. So it's one methyl group, and then on the third one will be the second methyl group. Okay, they don't have to be in opposite directions. I just find that it's a bit easier to draw when you do it in opposite directions, but they can be in the same direction. But this is essentially what it would look like. Okay, just fill in all your H's. Okay, that would be the answer for 2.1. Then question 2.2 asks you for the homologous series that you see here. Okay, I'm sure it's quite easy to see that it would be an alkene. Okay, it gives you the general formula CnH2n, and it gives you the structural formula. It asks you for the IUPAC name. So let's have a look. So remember, we need the longest carbon chain, which includes the functional group. Now the functional group is here, which means that the longest carbon chain would go like that. So we'd have 1, 2, 3, 4, 5. So we're going to number closest to the functional group, which is from here. So we have 1, 2, 3, 4, 5. We can see that on the third one, we're going to have a methyl group. So we'll start by naming the methyl. So we'll say 3-methyl. Then there's 5, so it'll be pent. And then don't forget, now you have to actually tell me where the double bond is. So it's on the first carbon. So it's pent 1-ene. Okay. Then if we look at number 6, number 6 says give the IUPAC name for each of the following. So for 6.1, first thing we need to be able to identify is that it is a alkane. Okay, so we can see that it's just single bond saturated hydrocarbon. So then we can name it accordingly. So what I would recommend that you do is, if you struggle to see this, is to redraw this compound. Okay, if you really need to, you can redraw it. But yeah, then we'll continue. So it's 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. Okay, so we can clearly see that the longest carbon chain is going to be 7. So we go 1, 2, 3, 4, 5, 6, 7. Okay, so now we need to number closest so that we have the smallest numbers. Now if we number from this way, we're going to have 1, 2, 3, 4, 5, and 6. So we don't want 4, 5, and 6 if we can do 2, 3, and 4. So we're going to number from here 1, 2, 3, 4, 5, 6, 7. So we can see we have 2 methyl groups and we have 1 ethyl group. So remember, we start naming the ethyl first because of alphabetical order. So it'll be 4 ethyl then 2, 3 dash dimethyl. Don't forget the di because there's 2 of them. And then because it's 7 carbons, it'll be hept, and it's alkane, so it'll be heptane. And that's your answer there. Okay, then let's look at the next one. The next one I can see is an alkene because there's a double bond. So I know it's going to end in ENE. So let's now do the longest carbon chain. And remember, we must include the double bond. So if we start here, we'll go 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. You can also go that way, or you can go 1, 2, 3, 4, 5. That won't work. So the longest carbon chain is going to be 6 carbons. So it'll be hexene. So we go 1, 2, 3, 4, 5, 6. Okay, you could also have gone this way. It would have given you the same, it will still give you the same answer. So let's number closest to the double bond. So we have 1, 2, 3, 4, 5, 6. So it will be 3, 4 dash diethyl and then hex that's on the second carbon, 2 ene. Okay, then moving to 6.3, I can see again it's just an alkane, so I'm going to see my longest carbon chain. So let's go 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we can clearly see the longest carbon chain is going to be 5. So we'll do 1, 2, 3, 4, 5. Make sure, even though it's 5, you can't go 1, 2, 3, 4, 5 because we don't have a name for this type of side chain at the moment. So we can't choose that one. So we'll number then closest to the nearest substituent. Okay, so we're going to have 1, 2, 3, 4, 5. So we have an ethyl group and we have a methyl group. So we'll name the ethyl first. So it'll be 3 ethyl dash 2 dash methyl pentane. Okay, then number 7 says give the structural formula as well as the IUPAC name for the following. Okay, so 7.1 says, so we have CH3, so we have 1C, 3 hydrogens. Okay, so we've done that part. Then CH2 4 times, so we have 1, 2, 3, 4 with H2s. Okay, so we've done that part. Don't get confused, this isn't a bracket for substituent. Okay, then I can see it's a bond to O, C, double bond O, C, H2, CH3. Okay, then it says it wants to know what the IUPAC name is for this. So we can clearly see that we have an ester. So I'm going to start with the alcohol first. So I can see the alcohol is the side nearest to the single bond oxygen, which is here. So I have 1, 2, 3, 4, 5 carbons. So that's going to be pent. So because this is pentanol, it will change to pentyl. And then I can see the carboxylic acid side is 3, so that's propanoic acid, which is going to change to propanoate. Okay, and that's the name for this compound. Then let's look at 7.2. So 7.2 starts with a CH3. So we'll do CH3. Then CH2 twice. So we have CH2 twice. Then it goes O, and then it doesn't give you the bond, but we know that there must be a bond between the C, and then there's a double bond O. So it will be O, C, double bond O. Then CH2 3 times. So we have 1, 2, 3 H2s. And then it ends in CH3. Okay, then I'm going to name this. So again, I can see that it's just going to be a ester. We have the alcohol and we have the carboxylic acid. So we're going to have 1, 2, 3 for the alcohol. So that's going to be pentanol, which will change to, not pen, sorry, prop. Propanol, which will change to propyl. And then we have 1, 2, 3, 4, 5 on carbons for the carboxylic acid. So that's pentanoic acid, which will change to pentanoate. Okay, and that's the answer, propyl pentanoate. Okay, so those are the answers to the questions that I gave you. Okay, so you can then rule off, you can write the date, which will be the, I believe it will be the 7th, if I'm not mistaken, of May. Yeah, Wednesday, the 7th of May. And the heading is the isomers now. So we look at isomers. Okay, so the isomers that we look at specifically in matric are structural isomers. So, structural isomers are essentially isomers, they are compounds that have the same molecular formula, but they'll have a different structural formula. So this is a SAG's definition that you have to know. So the SAG's definition defines a structural isomer as a compound having, well, not a compound, sorry, just compounds, because it would be 2, right? Compounds having the same molecular formula but different structural formulas. But different structural formulae. Okay, so that's one of the SAG's definitions that you need to be able to define. So there are three types of structural isomers that we look at. We look at chain isomers, so I'll write the three types. So the first type that we look at are called chain isomers. Now, a chain isomer is an isomer where they have the same molecular formula, just like any other structural formula will have, but a different type of chain structure. Type of chain structure. Okay, so an example of a chain isomer, of two chain isomers, would be if we took something like butane. So if we see butane, right, it has 1, 2, 3, 4 carbons surrounded by the hydrogens. So if we look at the formula, we would have C4 and then H. Remember, it's an alkane, so it's 2N, which will be 8 plus 2, which is going to be 10. You can double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the molecular formula, right? But if I had to create a side chain, I would have methyl propane, and we'll do, to be more accurate, 2-methyl propane. So we'll see it will be propane and then a methyl group on that second carbon. So we double check 1, 2, 3, 4 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So that's why these are isomers, because they have the same molecular formula. So notice that these two are the same. So the reason why this particular isomer is a chain isomer is because we are essentially changing the side chains. That's what's basically happening. So we are either adding side chains or we are removing side chains. Okay, then the next type of isomer is called a positional isomer. So the word positional isomer kind of gives itself away as to what it is. So it is compounds that have the same molecular formula again, and the same functional group, the same functional group. Okay, so we can't change the homologous series, but in a different position. So the functional group will be in a different position to what it was before. Okay, so if we look, an example would be propan 1-ol, which would have 1, 2, 3 carbons, and I can see that the alcohol is on number 1, the hydroxyl group. So the functional group is there, And the other one, I'm sure you can imagine, is going to change it to propan 2-ol. So I don't change the functional group and I don't change the longest carbon chain. All I'm changing is I'm just moving the functional group to a different carbon. So in this case, I move it from the number 1 to the second one. Okay, and let's double check. We have 1, 2, 3 carbons. 1, 2, 3, 4, 5, 6, 7 H's, and then you can end it in OH, or you can have C3H8O. And then I can see this one is 1, 2, 3 carbons, 1, 2, 3, 4, 5, 6, 7 hydrogens, and that OH group, or you can say again C3H8O. Okay, so that would be examples of positional isomers. So now I want to ask you, if I consider this one, propan 1-ol, okay, and then I move the functional group to the second one here, what would happen if I move it to the third carbon? So it was originally on the first one, and then I put on the second one here. Now, what if I put it on the third carbon here? Is that a third isomer? So does this, do these compounds share a third isomer here? Okay, this, pause, take a moment to think about it. So if you actually had a look, you would see, well, if the functional group is here, we always number closest to the functional group. So if the functional group is on this carbon here, then that one would by default become number 1, 2, and 3. So do you notice again we've just drawn propan 1-ol. So be very careful. So be careful not to repeat isomers, because this one is not a third isomer. Okay, it's the same as the one that we just drew above. So be very careful, because that's a common error here in isomers, is that you think, oh, this is a different isomer, but it's not true because it's going to move. Okay, and then the last type of isomer is called a functional isomer. So we'll only look at one type of functional isomer in the IB, and that is when you have compounds with the same molecular formula but a different functional group. So take a moment, pause, go look at all the functional groups and try and see if you can guess which two functional groups are isomers of each other. Remember, they have to have the same molecular formula, so they must have the same type of atoms. Okay, so the functional isomer that we are going to look at is going to be carboxylic acids and esters. Okay, we don't look at alkenes and alkanes because technically they do have different functional groups, but the one has a double bond C's and the other one has single bond C's. So they're not the same, they're not actually the same. But if we look at a carboxylic acid, so if we looked at an example like propanoic acid, we would notice, okay, well, we have 3 carbons, and on the last carbon is that carboxyl group. And then let's say then I took this double bond, single bond O, and I decided to move them to this middle carbon there. So I would still have the 3, and then I would have now my carbon with the double bond O, single bond O, C, and then H's would surround that one. Now let's double check. Okay, so this one would be methyl ethanoate. Okay, I'm not going to go over precisely how I got to the name. Okay, I'm sure by now we know how to name this. So my goal is to double check. Okay, I have 1, 2, 3 carbons, C3. I have 1, 2, 3, 4, 5, 6 hydrogens and 2 oxygens. And then the one on the left, I have 1, 2, 3 carbons. I have 1, 2, 3, 4, 5, 6 hydrogens and 2 oxygens. So again, the same molecular formula, but because I've basically moved the functional group in such a way that I've completely changed the homologous series entirely. Okay, and that happens, we look at it between esters and carboxylic acids. Okay, so what I've done is I've basically pulled questions out from all the exercises that we've done from the beginning of the unit, and I've just pulled out all the questions that technically we would have skipped over because we hadn't done isomers until now. And you see why we actually left isomers for last, because you won't actually be able to understand how a functional isomer or a positional isomer or the chain isomer would work until you know everything about the naming and everything about the homologous series. So now we can actually do it, and we can do it properly. So if we look at the first question, the first example comes from exercise 34. It was number 2.2. So pause and then take a moment to obviously check, go to this page, and we can answer then the remaining questions. So you can say isomer questions and then just make reference of where in the textbook you are getting the questions from. So it says, give the structural formula for 4 positional isomers of compound F. The IUPAC names are not necessary. Okay, so compound F is this one here. So they want to know 4 positional isomers. So let's have a look and see. Well, compound F is a haloalkane, and it has 2 halogens. It has a chlorine and it has a bromine. So let's leave the longest carbon chain, because all we're going to do is we're going to move around the functional groups. So I'm going to draw 1, 2, 3 carbons with all their bonds around, because essentially this would be the base of all of the isomers, right? Because I'm not changing the molecular formula, and I'm also not changing the functional group. And I'm not adding chains either. Okay, it's a positional isomer, which just means that the chlorine and the bromine are going to move around. So what I recommend then that you do is that you take note. So it says IUPAC names are not necessary. So I have number 1, number 2, and number 3. So I can see with this one, the chlorine is on number 1, and the bromine is on number 2. So take a moment and think, how could you move these around in order to get a different compound? So I can see that, well, the easiest way would be to swap them around. So to put the bromine on the first one and the chlorine on the second one. Okay, that would be a positional isomer, because what I've done is I've changed the position of the bromine and changed the position of the chlorine. Okay, so what I could also do is I could put them on the same carbon. So maybe then I'll put it in the middle. So I'll have a chlorine here and a bromine here. Remember, it's 2, 2. And that changes it. So I can see that the chlorine and the bromine now are on the same carbon. But now what if I wanted that same carbon to be the end carbon? I could also do that. So I could say, well, if this is chlorine and that's bromine, that's also a positional isomer, because now I've moved them to the same carbon, but now on the opposite, on the far end, the terminating carbon. Now I want you to take a moment and pause and try think, what else can you think of? What have we perhaps missed in this one? Last one. So I can tell, well, we can't move it to on the same one here. We've already done them on the same one in the middle, the same one on the terminating. We've done one in the middle, one on the side, and then one in the middle, one on the side. But what if we put them both on opposite sides? That could be an isomer. So if I had Cl on this side and Br on that side, there I've created a fourth isomer. So the main thing is to make sure that you haven't changed the functional group, you haven't changed the number of anything else, so you still have 3 carbons for every one, and 1, 2, 3, 4, 5, 6 hydrogens at every single point. And then you just make sure that you've essentially moved it in such a way that each functional group is at a different position. Okay, so it can be a bit tricky, but the more you practice it, the easier it will become. So 2.3 says, give the structural formula for a structural isomer or the chain of compound G. The IUPAC names are not necessary. So compound G is butane. So compound G is this one here. So they say that I must draw a chain isomer for that compound. So the chain isomer would be to decrease the length of that carbon chain. So I could do that by making it into propane, and then now we need to think, okay, well, where would I add the side chain? Can I add the side chain here? No, because it will just form part of that longest carbon chain again, and all I have here is butane, which is the same here. So this won't work, which means the only place I can move it is to the central carbon. So then I will have H, H, H all around. Okay, double check. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so make sure that you've done this. And remember, do this one in pencil. If this was an exam, okay, this one that you do in pencil, you want to put a line through it. Because if I'm a marker and I see you draw both of them, then I'm not going to, remember, it's not me that's supposed to choose between 2 drawings which one is the right drawing. So you can't, and they are very strict in the sense that they will mark the first thing that they see. So if you do this first and then this later, they're going to mark this one. Okay, it's not up to me to choose, oh, is it A or is it B? No. So put a line through your working and make sure that your first answer is your final answer. Okay. Then 2.4, it says give the structural formula for a position isomer of compound D. The IUPAC name is not necessary. So D is I can see is an alcohol. It's butane 1-ol. So it says a positional isomer. So if butane 1-ol is like that, then I can see that the positional isomer would then be on one of the central carbons. So you can put it on the second one. What would happen if I moved this oxygen onto the third carbon? It would technically then become the second carbon because I would start numbering closest to that side chain. So there's only one isomer, one positional isomer for this, and it's that one there. Okay, so make sure you put a line through your working. Okay, then the next one is exercise 35, number 4. It said refer to L, which is hexane. Then it said give the structural formula for hexane. So hexane is just a simple 6-carbon chain alkane. So make sure that you put in all your hydrogens. I know it can become a bit tedious to keep redrawing these, but it's good to practice them. Okay, so if we're going to continue, we'll see that we have the last H's there. Okay, and then 4.2 says give the structural formulae and IUPAC names for all possible isomers of L. So we'll have a look. It says if they want a structural formula, then we have to of all possible structural isomers of L. So if we think about this, right, you can't, between the 3 isomers, right, you cannot change the functional group. Okay, you can't do a functional isomer. That would be impossible. And a functional isomer is only between carboxylic acids and esters. Now, if you think about the other type of isomer, the positional isomer, you can't move the functional group around, right? It would be impossible because it's like, okay, well, the functional group is a single bond carbon, which is everywhere. So that's not going to help, which means that the only possible isomer that you could draw here for a structural isomer is a chain isomer. Okay, so don't now think, oh, no, they didn't tell me which type of isomer. Okay, you must also think about it because logically you can only do a chain isomer. Okay, so it says they want the names of all possible isomers. So this one, it's always good to look at a mark allocation, but in this case, we're just going to try and see how many we can do. So I can see that, well, the only thing you can do is reduce your longest carbon chain. So let's start with 5 carbons then. So we'll do the first one will be 1, 2, 3, 4, 5. And then let's put a side chain on any terminal, on any carbon except the terminating ones. So if I do that, let's double check and see. So I have all these H's. Double check. So 1, 2, 3, 4, 5, 6, and we need, I think it's going to be 14, because it'll be 6 times 2, which is 12, plus 2, which is 14. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm happy with that. I'll give the name, which is going to be 2-methyl pentane. Okay, so Now let's have a look. What would happen, I could also move that side chain to the middle. I would have a different compound. So that is not a positional isomer, it's still a chain isomer. I've just moved the chain to the third one. So I'll still have 5. But now instead of on the second one, I'm going to put it on the third one. So if I count, I'll see, okay, well, I have 3 methyl pentane. What if I then moved this side chain to the fourth one? Can I do that? No, because if you do that, then it's going to turn this into 1, 2, and then you have 2 methyl pentane again. Okay, so then technically I've exceeded, because I can't do my last ones, I've already done the second ones and I've done the third one. So I've exceeded my limit on the pentanes. So let's then try and reduce our carbon chain again. So let's try now 4 carbons. 1, 2, 3, 4. Now remember, we still need 6 carbons. So I can't put another carbon here because that's going to just form part of this longest carbon chain again. So I'm going to have to put a carbon here. Now remember, you need to have 2 of them. So I'm not going to put it here because if I put it there, then I'm not going to have an ethyl group. I'm going to have the longest carbon chain being 5 again. So be careful of where you place these carbons, okay, because you might end up repeating yourself, like I said earlier. So the alternative is to put it on the other carbon. So I have all my H's, and double check that you've done it correctly. So you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you can see when you name it that you're going to have 2, 3 dash dimethyl butane. Okay, so I can see that that's definitely going to be different because I even have a different name. Okay, then is there any more that I could possibly do? Well, I can see an additional one. I can still use my 4, and then I could keep that one side chain there and just put a second side chain on the same carbon. And you can double check that it doesn't affect your longest carbon chain, that your longest carbon chain will still be butane, because you can't go 3, you can only go 4, or you can go 4 this way, or you can go 4 that way. It will still give you the same. So I'll number it 2, 2 dimethyl butane. Okay, and if you think about it, you can't really go to 3, because if you go 3, then you're only going to be able to add 1 here, and then you're going to have to add a 6th one. And then if you do that, then you're just going to take 1, 2, 3, you're going to have bute again. So you see, you can't go to 3. So the highest possible number will be 4. So like I said, in an exam situation, you can always try and look at the mark allocation to guide you. Okay, then we can try exercise 36 on page 276. So we have number 4. It says give the structural formula and IUPAC name for the following. So 4.1 is the positional isomer of compound G, and 4.2 is the chain isomer of compound G. So pause, try it yourself, and then we can go through it together. Okay, so it's butene. So if they want a positional isomer, then I'm moving it around. So I would recommend that you first draw the structural formula for this one. 1, 2, 3, 4. But 2-ene, it's an alkene, and it'll be on the second carbon. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Double check that you haven't drawn any extra hydrogens. Okay, and it should technically match the 1, 2, 3, 4, and there should be 8. 1, 2, 3, 4, 5, 6, 7, 8 because of the general formula. So if I decide to do a positional isomer, I could always move this to the first one. So I would have C double bond C 2, 3, then 2 hydrogens here, 1 hydrogen, 2 hydrogens, 3 hydrogens. Count, double check. 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So then this one would become but 1-ene. Okay, then it says it wants a chain isomer of compound G. Okay, so if they want a chain isomer, then what we need to do is we need to decrease the longest carbon chain, because that's the only way we can get to a chain. So we'll have 1, 2 with a double bond on either carbon. Remember, it will be on one of the terminating carbons, because obviously if you put it on this carbon, it will still be on this terminating carbon. So that means that the only place that I would have a side chain would have to be on this center carbon, because if you put it on this carbon here, you're just going to have but again. So the only way to do it is to put the side chain on the central carbon. Remember, I said it is a little bit tricky, so you have to practice it. And then if I name it, I can see the longest carbon chain is 3 with a methyl group on the second carbon. So I'm going to have 2-methyl prop. And then don't forget your rules of naming. It's going to be prop 1. Well, I guess with this one, it can only be on 1, so you don't have to worry about putting the 1. You can just say propene. Okay, as far as I know, I don't think you will get marked down, but just be careful, because, I mean, you don't actually have to put the 1, so we wouldn't put the 1 here because it has to be on 1. Okay, then exercise 38 on page 280 was number 3. It just asked you for the structural formula and IUPAC name of the positional isomer for compound D, which was propan 1-ol. Okay, so propan 1-ol again starts with writing out the formula, and then pause the video and try and see, can you figure out a positional isomer for this one? Okay, so hopefully you realize that the positional isomer is not too tricky. All you have to do is just keep your longest carbon chain and just move your hydroxyl group to the center carbon. So that will change now to propan 2-ol. Okay, then the last one, exercise 39, says number 3 was to give the IUPAC name and structural formula of ethyl methanoate. Sorry if there was a bit of noise in the back. So functional isomer of ethyl methanoate starts then, like we've been doing, by doing the structural formula for ethyl methanoate first. So I can see it's going to be a ester, right, methanoate. So I'm going to start with the alcohol. Ethyl is 2. then it's the O, then C double bond O, then methanoate is just one carbon, so I already have the carbon there, so I just entered with the hydrogen. Okay, now it says I need to move the functional group so that I have a functional isomer. So the functional isomer, I'm going to see the only way to move the functional isomer is to move this O and this O, single bond O, double bond oxygen to the end. So if you're going to do a functional isomer and you're going to change the functional isomer, and you know, oh well, it must be between a carboxylic acid and an ester, then you know, well, if I have an ester, I'm going to have to change it to a carboxylic acid. So by doing that, I'll say, okay, well, if there's 3 carbons, then you must have the 3 carbons in your carboxylic acid as well. And notice that you can count 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens. So you will just have propanoic acid. Okay, so yeah, usual general knowledge. You don't have to struggle with something like this, and then you can definitely see that it's quite manageable. Okay, so then that's the end of isomers. So I hope that it made sense. Make sure you go over, if you need to still just repeat the lesson for yourself. But your homework is going to be from the exam questions again. So this is a part 2 now of the exam questions from page 298. So I want you to do, it's going to be from the structured questions again. Number 1. It's number 1, number 3, 4, and 5, 8, 9, and 10. Okay, so number 1, 3, 4, and 5, and I think 8, 9, and 10. Okay, but again, like I said in the previous video, check Google Classroom to make sure that you've done all the homework that I've specified there. And don't forget that today I would have released the multiple choice questions. So make sure that you first do this homework and that you understand everything that's going on here before attempting to do the multiple choice. And then when you feel that you're ready, then you can answer the multiple choice questions on the Google form. Okay. I hope that it makes sense. I hope that you're finding the videos helpful, and I'll see you on the next one. Bye-bye.